Have you ever noticed that the sound of an ambulance siren changes as it comes closer and then goes away? This is called the Doppler effect. The Doppler effect means a change in frequency and wavelength of a wave when the source or the observer is moving. Frequency depends on distance. Wavelength depends on the motion of the source. First, let's look at frequency. If the distance between source and observer becomes smaller, the frequency increases and the sound is higher. If the distance becomes larger, the frequency decreases and the sound is lower. Now, let's look at wavelength. If the source is not moving, the wavelength stays the same in all directions. If the source is moving, the waves in front of it are compressed, so the wavelength becomes shorter. Behind the moving source, the waves are stretched, so the wavelength becomes longer. Now let's test all possible cases one by one. Case 1. Observer is still. Source is moving toward the observer. Frequency increases. Higher pitch. Wavelength in front of the source becomes shorter. Case 2. Observer is still. Source is moving away from the observer. Frequency decreases. Lower pitch. Wavelength behind the source becomes longer. Case 3. Both observer and source are still. Frequency stays the same. Wavelength stays the same. Case 4. Observer is moving toward the source. Source is still. Frequency increases. Higher pitch. Wavelength does not change as the source is not moving. Case 5. Observer is moving away from the source. Source is still. Frequency decreases. Lower pitch. Wavelength does not change. Case 6. The source and the object are moving away from each other. Frequency decreases. Wavelength behind the source becomes longer. Case 7. Observer and source are moving towards each other. Frequency increases strongly. Wavelength in front of the source becomes shorter. When both move towards each other, the effect is even stronger. And remember, the Doppler effect is not only for sound, but also for light and all kinds of waves. That's why scientists use it in astronomy, medicine, and even in daily life. Thanks for watching. If you liked this lesson, hit like and subscribe for more fun physics.